Welcome to Topic 10. In this topic, we'll explore the way that business is evolving to use data-driven decision-making approaches like data science. We'll also discuss the role of data and data scientists in the modern business. Science has evolved through a number of discrete stages. Originally, science was based on empirical observation. Scientific progress was made by observing the world and its basic properties. Scientists were just inquisitive men and women. Much later, science entered a theoretical stage, where progress was made by mathematically advancing known empirical theory. Mathematicians and physicists were the primary drivers of this phase. More recently, science entered a computational phase. Computing power has rendered many complex mathematical techniques somewhat obsolete. Rather than empowering a particular discipline, computers have helped all scientific fields advance rapidly. Huge leap forwards in computing power have allowed changes to the basic scientific method. The historical paradigm of creating a theory and looking for data to prove or disprove it is becoming replaced with obtaining large amounts of data and seeing what the data tells us. Science is all about asking questions. Traditionally, data acquisition activities were coupled to a specific hypothesis, but in the e-science world, we consider we can download the entire world. While this may not be strictly true, we can now download immense amounts of data, and the question is, what does the data tell us, as opposed to what is our hypothesis? It's important to be able to understand the difference in the question that's being asked. The traditional question was, what is my hypothesis, and can I find data to support it? The e-science question is, what does the data tell us? So why is there so much data? Well, the cost of data acquisition has dropped precipitously thanks to advantages in technology. In the next few slides, we'll look at some of the kind of techniques which generate immense amounts of data. The cost of finding, integrating and analyzing data and then communicating the results back is now the new bottleneck. When we look at some modern data collection devices, it's easy to see how there's a huge amount of data available. Let's look at a few examples of these massive data collection devices. Here we see a picture of the Apache Point telescope, and underneath we see the huge amount of data, raw image data, that has been collected. Here we see the Large Synoptic Survey Telescope, and a huge amount of data that it can collect. This is a device known as Illumina High Sequence 2000 sequencer for sequencing genomes. And here we see the effect of the regional scale nodes of the NSF Ocean Observatories Initiative, which is effectively 1,000 kilometers of fiber optic cable on the seafloor, connecting thousands of chemical, physical and biological sensors about the Earth. And finally, of course, the internet or the web itself, 20+ billion web pages. I think you'll find this link quite illuminating. Take a moment to click on this link 1 second on the internet and familiarize yourself with the amount of information that is being generated in every second. This shows the massive amount of data being generated every second just by human beings interacting. So e-science is about the analysis of data, the automated or semi-automated extraction of knowledge from massive volumes of data. There's simply too much data to just look at. And remember, it's not simply a matter of volume. We talk about the 3 V's of big data: volume, variety, and velocity. Volume talks about the number of rows or just the size of the actual data. Variety talks about the number of different sources and dimensions and columns available, while velocity talks about the speed that the data comes at. And many people like to add on a fourth V, veracity, which means can we actually trust this data? Huge amounts of data, for example, are generated by human beings interacting. But is this data all facts? So science is in the middle of a generational shift from a data-poor enterprise to a data-rich enterprise. Data analysis has replaced the data acquisition as the new bottleneck to discovery. You're probably asking yourself the question, what does all this have to do with my business? But business is now beginning to look a lot like science. Modern businesses now acquire data aggressively and protect it. They hire data scientists, and they use this data to make empirical decisions.